Hi, everyone. Thank you for joining this introductory session on AWS storage services. Seems like I'm the last hurdle before you and happy hour, but the exciting news is we've got some interesting content to share with you today. My name is Guy Farber. I'm a business development manager with Amazon Web Services, and what originally fascinated me about data storage is it's always growing. And my goal today is to show you how you can leverage our powerful cloud storage services to better handle and effectively manage the growth of data. So we have multiple storage services and platforms, and the reason we have them is because data and applications come in different shapes and sizes. You have different data interface requirements. You have different performance and cost requirements. And so today, we're going to talk first about scalable object storage, which is an optimal platform to deal with volume and velocity that comes from internet-based web applications. We'll talk about how to cost-effectively manage deep archives and long-term backup, so data sets that are not very frequently accessed. How to provide block storage access for EC2, our compute service. And I'm going to provide more detail about the exciting announcement that Andy Jassy made today about our cloud-based shared file system. And then finally, discuss a turnkey gateway solution that allows you to very easily ingest backup and archive data into our services from your on-premises data center. Let me give you some motivation to start. We, as consumers, we walk around and we record pretty much every moment and every experience that comes in our way. And we expect to be able to share and retrieve those photos and those videos at any moment in time. And this creates just a huge volume and velocity of data that traditional storage systems were not designed to accommodate. And this doesn't just come from consumers, but also from new industry solutions, anywhere from the financial services industry, where they run very complex risk simulations and fraud detection techniques, to the media and entertainment industry, where new movie productions weigh in at tens of petabytes per movie, per production, to the online advertising industry, and I'm giving you a nice illustration here, where they're tracking your usage patterns and then making sure they're only going to display ads that are relevant to what you're looking for, what you're shopping. So it's a win-win because advertisers are getting a really good ROI, and consumers don't need to look at ads of things they're not interested in. Object storage is the optimal approach or platform for web-scale data. The difference between file storage or a file system and object storage, to those of you who are not familiar, is that object is a file that has associated metadata stored with it, rather than separately in a file system index. Some other differences are that an object store is completely flat namespace, doesn't have any directory hierarchical structure, and also that when you want to write a change to a file, when you want to edit a file, it'll just write a new version of the object. So it'll write a new file entirely. And what this approach buys us is tremendous scalability and durability, and we'll get some details on that. Amazon's object storage platform is called S3, or Simple Storage Service. And this may sound like an oxymoron to people who have been in the storage industry for a long time, because storage is associated with pain, suffering, and complexity. But the way S3 makes it really simple is we deliver it as a managed service. So we take care of all the storage provisioning and heavy lifting for you. We scale it for capacity. We scale it for performance purposes. And all your application has to do is to put objects through our HTTP-based APIs and get objects. It's a really simple paradigm. S3 has been around for a very long time. It's actually the first service that Amazon Web Services launched 9 years ago. So it's very mature. It's got a really strong track record of operational performance. And we have pretty much our customers run the gamut of use cases and and industries, anywhere from Dropbox, who is using us for content collaboration for consumers and businesses, Pinterest, who's storing all the pins, the photos on S3, as well as their massive logs that they use for big data analytics, to Netflix, who's using us for their video streaming service. Our customers love S3 because of its scalability. So customers no longer have to worry about buying enough capacity ahead of time to accommodate the amount of data that they'll need to store over the next 3, 4, or 5 years, or designing storage system, the wasteful practice of designing storage systems to accommodate peak I/O. Instead of that, you can just rely on the scalability of S3 to deliver that. An interesting metric that Angie Jassy presented today during his keynote is that Amazon S3 is still growing at a very rapid clip. Over the past year, data transfer in and out of S3 grew by a factor of 102%. So we're still adding a lot of large customers, and some of our existing customers are growing very rapidly. Customers love S3 also because of its durability. So now, when your application puts an object into S3, we automatically replicate it across 3 fault isolated facilities within a region before we acknowledge the request back to the application. In this state, we can sustain a full facility failure, so a full data center failure, in addition to other concurrent device failures in the 2 other facilities. Imagine what it would take for you to build an architecture like this, a disaster recovery plan like this, on your own. And even the recovery process is handled automatically for you behind the scenes. So if we have a device failure, we'll recover it, and your application is not going to even notice. The statistical measure we derive out of that is 11 nines of durability. But there are data sets that are very easily reproducible, or at a very low cost, or just temporary data in nature that doesn't need that level of durability. So a few years ago, we introduced a different class of S3, which is called reduced redundancy option. This only has 4 nines of durability, which is still a lot higher than most traditional storage systems, and costs you, on average, if you look at our public pricing, 20% less. It's very easy for you to blend use of these 2 storage classes for different data sets. So let's kind of give you a quick overview of how the architecture looks like. So you have an application that wants to read and write from S3. The first thing you need to do is to choose an AWS region. S3 is available out of 11 global regions worldwide. Once you choose a region, you create a container called a bucket. A bucket is not a physical container that you're used to in the traditional storage world. It's a virtual container. So it's unlimited in terms of capacity, and it's unlimited in terms of the number of objects that you can store in it. So basically, it's the scale of the service. But what it allows you to do is organize your data administratively. So you can assign different buckets to different groups within a large organization, for example. And also allows you to simplify tracking data for chargebacks. Once you create that bucket, you can start putting and getting objects from that bucket. The way you do it is by requesting API calls into an S3 endpoint. The endpoint would be an HTTP one, and would look like bucketname.amazonaws.com/the object name. You can use your own company's domain name by using a DNS in front of S3. Which brings us to a very cool feature of S3. Because S3 is not just a storage system, it's actually a web service. It also provides you with the opportunity of offloading all your static web serving onto S3. So you can deliver static objects such as images, HTML pages, cascading style sheets, and so forth directly from S3 and rely on its durability, high availability, and ease of provisioning to now also offload your static web pages while running your dynamic web pages off of web servers running on EC2. So far, sounds pretty interesting, some compelling value propositions. But what about the cost? How much does it cost? Before I tell you how much it costs, let's talk about what you're paying for and compare that to traditional storage. With traditional storage, you buy something called raw storage. The reason we call it raw is because you don't actually get to use it. It's just what you pay for. And then it's sort of like the layers of an onion, the levels of overhead in that storage system. The first thing you have to kind of take out of the equation is data protection. So whether you use RAID or you use erasure coding, it's going to apply some overhead to protect your data. So in my example, that took us down from a petabyte to 800 terabytes. Then I need to store metadata. Whether this is a file system or an object store, I need to have some spare space for metadata. My example takes us down to 600 terabytes. But even those 600 terabytes are not available to your application for use because you need to leave some reserve capacity for free space. You can never afford to run out of space because that usually means an outage, which usually means you need to refresh your resume. And also, because certain systems just can't afford to perform at peak capacity. The performance becomes pretty bad, so you need to leave a little bit of room. So in my example, we're left with 400 terabytes, and this is even before you start making disaster recovery replicas. With S3, even after all of the data protection mechanisms that we apply, you only pay for what you use. So in this example, it's 400 terabytes. If you start the month with 400 terabytes and then you end it with 400 terabytes, this is what you're going to pay for. And the metric or the measure for what you pay for is gigabytes per month. So all of our pricing is public. And like I said, S3 is available out of 11 global regions. If you see the photo, the screenshot I took here, you can see our pricing in our core regions. So it's tiered pricing, and it's 3 cents per gig per month or lower, depending on how much you use. You can also see the pricing for reduced redundancy. In some of our regions where our costs are a little bit higher, such as Latin America, the pricing is going to be slightly higher as well. So take this pricing when you start making these apples-to-apples comparisons, as TCO comparisons with traditional storage. The other thing you should take into account that people rarely do is that we have a really strong history of price reductions. As a matter of fact, we already reduced pricing since the service launched a total of 8 times. Last year, we reduced our pricing by average of 65%, and our most recent price reduction, which happened April of last year, was on average 51%. So when you look at a TCO of 3, 4, or 5 years, if you're not taking a measure of an expected price reduction, you're not really making an apples-to-apples comparison. We know the TCO modeling is very complex, and so we have a dedicated team of experts that's available to work with you. If you drop me an email or contact your account team, we'd be happy to engage you and make that comparison for you. One of the emerging use cases we see on S3 is leveraging S3 for staging and persistent storage of big data analytics. And an example of a customer that leveraged these capabilities is Yelp. Yelp is the leading social network for local businesses and customer reviews. They load their logs into S3 for analysis in AWS services such as Elastic MapReduce and our data warehouse, Redshift. And this capability powers features such as autocomplete as you type, their ad placement, as well as review highlights. They also use S3 to store all the images that are uploaded by businesses and users into the application. Let's talk a little bit about some S3 new features for those of you who are already familiar with S3. In November at reInvent, we introduced a very powerful but simple-looking feature called S3 Event Notifications. The way this works is when you put an object into an S3 bucket, we will generate a notification immediately that goes into one of 3 Amazon facilities. The first one is SNS, our push notification service. Second one is putting a message into a queue, into our simple queuing service, which then can be picked up by an EC2 worker for further processing. And the most interesting one, in my view, is sending a notification to our Lambda service, which is our event-based computing service that allows you to run very simple pieces of code triggered by events and without the need to provision any infrastructure. So let me kind of illustrate an example for you how powerful this is. Imagine we have an application that allows users to upload high-res photos. Could be a dating application, photo management, whatever you like. The user uploads the high-resolution photo directly into S3. S3 triggers an event notification that then triggers Lambda functions, which would then automatically process the image for a thumbnail and also resize it to fit the different mobile devices that we want our application to support. Finally, it drops it in the right place into the S3 bucket, which can then statically serve it immediately to the user. So what we got here is just pretty much automatic, instantaneous resizing and creating of thumbnails with very little additional code required. Powerful stuff. S3 versioning is not a new feature, but we significantly improved it last year. So when do you use S3 versioning? Why is it so important for me to talk about it today? Because it augments our durability story that physically protects your data with logical data protection. This is where you protect yourself from the human factor, for human error, and from logical data corruption. By every time your application or a user makes a change to an existing object, we will keep all the previous versions of that object. So some customers came to us and said, you know, this is a really powerful feature, but I'm really concerned that my costs are going to go out of control because you're going to keep all of my versions, and now I have to rely on my developers to clean up those versions. So last year, we introduced support for lifecycle policies that can basically recycle old versions according to a policy. So I can, for example, say that I don't want to keep any older versions for longer than a week. And then that became a really powerful feature at that point. It's really easy to turn it on using our console, and you do it at a bucket level. A feature that we introduced a few weeks ago was we saw very high demand from customers is S3 cross-region replication. So S3, again, has a very strong disaster recovery built in at the region level. But certain customers told us, you know, we have compliance requirements to create a replica that's several hundreds of miles away. And you guys have regions all over the place, and you're now requiring us to copy the data ourselves to satisfy those regulations. This is why we introduced an automated facility to help you replicate these objects. The way this works today is that as soon as you turn on cross-region replication on a source bucket, every new object that gets created in it will be asynchronously copied to a destination bucket. So it doesn't affect your application from a performance standpoint. It's completely asynchronous. It works at an entire bucket granularity or even a prefix granularity. So I can just apply it to some of my objects. I don't have to replicate the entire bucket. Finally, at this stage, it works on a one-to-one basis, meaning you can't do chain replication following more than 2 buckets. The use cases for this feature, one, as I said, is compliance. Another one is being able to reduce the latency of some of your users by creating a secondary copy that's closer to your users, improving their experience and access to your application. The third use case is very interesting, is the security use case. We've had customers that were really happy about this because they said, you know, now I can replicate between 2 different AWS accounts. So I can replicate from one bucket owned by one set of AWS credentials to another one that's owned by a completely separate set of credentials. And this way, I can protect myself with very sensitive data sets from a malicious attack from within my organization. So I want to invite Sheng Kwan, who's the product manager that was responsible for launching this feature, to give you a quick but powerful demo.
Hi, everybody. My name is Sheng Kwan. I am a senior product manager on Amazon S3. As Guy mentioned, we're very excited about this new feature for S3, cross-region replication. I'm going to show you two things today. The first thing is I'm going to show you how to configure cross-region replication in the AWS Management Console. The second thing I'll show you is a live, more of a real-life use case where you can see replication happening in real time. So we are here at the, let me see here. Let me reload the console. So this is the landing page of the AWS console. And to enable replication, we're going to pick two buckets. One, a source bucket, and the second one, a destination bucket. On the source bucket, anything uploaded into that bucket will be automatically and asynchronously replicated to the destination bucket. I have two buckets here that I created earlier today, Xing Live Demo Dublin Destination and Xing Live Demo Oregon Source. What I will do is 3 steps. I will first turn on versioning, which Guy explained, and is a requirement for cross-region replication. Next, I will actually go through the cross-region replication workflow and have one bucket replicating to the next. And the third thing I'll do is enable an IAM role so that S3 has the necessary permissions to complete the replication. So I'm going to do this on the source bucket. And I'm going to first turn on versioning. I'm going to do this on the destination bucket as well. Let me try this again. There we go. Sure. Yeah, Lifecycle is a different capability we have in S3, and I'd be happy to answer questions about that at the end. So I've enabled versioning on both of my buckets. Now I'm going to go back to the source, and that's where I'm going to turn on replication. So the first option I have is I can choose to replicate the entire bucket namespace or just a prefix, as Guy mentioned. This gives you the flexibility of only having part of your bucket replicated if, for instance, you always want to replicate images slash, but maybe not necessarily log slash. For this demonstration, we're just going to replicate the entire bucket. And I'm going to choose the Ireland region, which is the, where my bucket is. And it is this Dublin destination. Here, I'm going to create an IAM role that contains the necessary permissions for S3 to do the replication. You can view the details of this and even edit it if you want to have further control over what gets replicated. For now, we're just going to allow the default. And then that's it. Now, that was fairly boring, I agree. So I wanted to show a more live action demo of how replication works. We have a customer, we actually have a bunch of customers that are using replication for operational and latency purposes in order to get a central view of data. A typical use case is they have EC2 web servers in multiple AWS regions writing logs locally to S3 buckets in the same region for low latency and performance reasons. Now, they also want a central view of all the logs in one place so they can run log analysis and they can run kind of detailed analysis on the entire data set. So the web app that my team built for this demonstration today is doing a version of that, except it's doing it with pictures. And I'm actually really lucky that they built this for me because it has a nice use for my family. You see, my family is a fairly multinational one. I'm located on the west coast of the United States. My older brother is located in Asia, and my parents are located in Europe. And what we're doing now is I upload all the pictures for my immediate family into a very low latency Oregon bucket. And I upload and download very low latency. My brother does the same thing to a bucket in Tokyo. And my mother, being kind of the head of the household, gets access to all of the pictures that we upload as a replica in her bucket in Ireland, which is very low latency for her as well. So let me show this really quickly. So I'm going to upload some pictures to the Oregon bucket, and I'm also going to upload a different set of pictures to the Tokyo bucket. And this has already been configured for replication. Both of these buckets are replicating into the central Ireland bucket. And as you see, as these guys show up, they also show up in the middle. And that's kind of the replication asynchronous nature that you're seeing. Now, I want to highlight a particular picture. Actually, I'll highlight a particular set of pictures. And this is just finishing up here. OK, so I'm going to pick this picture. Now, this is a picture of my baby daughter. I'm not using this picture just to show you how beautiful she is, but I actually want to point your attention to something. In the URL, you can see the bucket that this picture is being hosted out of. And the bucket is shing-demo-Ireland. Here, we have the exact same picture that's hosted out of shing-demo-Oregon. They are distinct files, distinct objects in two different buckets, but with the exact same data and also the exact same metadata. In this, I have version ID 7KDM, and on it goes. And here, I also have the exact same version ID 7KDM. And so it truly is an exact replica with the same metadata, same underlying data, and automatic asynchronous. So we are really excited to see what our customers build with this feature. And with that, I'll return to Guy.
You can probably hear him now. Oh, there we go. I personally think this was just a ploy for him to show you some photos of his daughter, but it seemed like a pretty cool demo too. So let's continue. So let's just recap the S3 use cases. The first use case is you want to build your own web scale web application, not have to worry about capacity or performance. Use S3 as the backend for that. If you want to deliver rich media, video streaming, music streaming, or deliver photos over a CDN such as Amazon CloudFront, you can use S3 as your durable single origin source. You can use it, as we discussed with the Yelp use case, for staging and persistent store for big data analytics jobs. And then finally, because it's so durable, inexpensive, and easy to set up, it's just a perfect target for backup and archives. So a lot of customers told us, we love S3's scalability and durability, but we have data sets that are very infrequently accessed, deep archives, long-term backup. They don't need the real-time capabilities of S3. So a few years ago, we developed Glacier to accommodate that. And what Glacier provides you, the value proposition is pretty simple. It's way cheaper. So instead of 3 cents per gig per month, roughly for S3, you're going to pay a third at a cent per gig per month. And I know it's very difficult to make calculations with gigabytes and months, so I've done the math for you. It's $120 per terabyte per year. So that's what you can go and compare to the cost of tape and the cost of disk-based storage. But you still get our favorite new metric of 11 nines of durability. So it's a similar durability level as S3 minus the cartoon this time, and it's already built into the price. The thing you do need to take into account with Glacier, the real trade-off, is that your data is now not available for retrieval in real time. It is similar in ways to a tape vaulting paradigm, right? When you vault your tapes, it takes you a day or two to retrieve them from the vaulting provider. Here, you have to wait 3 to 5 hours from the moment you asked us to retrieve data to get it ready for you to the moment you can actually start downloading it. Another consideration with Glacier, as you compare it to S3 and decide what to use, is that because it was designed for deep archives, for very infrequently accessed data, we provide you with 5% of your overall capacity as a free retrieval tier. Above that level, we will charge you retrieval fees. So for example, if you have 100 terabytes stored in Glacier, you can retrieve 5 terabytes in a month. Above that, we'll charge you retrieval fees. The rule of thumb that I came up with that seems to work for most customers is if you think you're going to retrieve close to 10% of your overall capacity, it's not going to break even. It's not going to be financially beneficial to use Glacier over S3. So keep these things into account. What are the benefits of Glacier? Pretty trivial stuff. You can reduce the cost of storing deep archives and long-term backup. With archives, you usually keep adding data. You don't delete data. So you want something that provides you with unlimited capacity and never having to worry about that. It's a great opportunity for you to replace all your tape museums, where you keep adding newer and newer tape libraries. And every few years, because LTO has compatibility only 2 generations back, you have to rehydrate all your old backups and back them up again. So you can avoid that painful practice by just moving into Glacier gradually. And then finally, we all know that tape is a great medium to back up into. It's just not so good for restores. You always have to pray when you restore from a really old backup set. Here, you have a chance to improve your durability all the way to the other end of the spectrum with 11 nines of durability. This story gets even better because these 2 services are tightly integrated together, S3 and Glacier, through a mechanism we call Lifecycle Policies. The way Lifecycle Policies work is pretty simple. I can take a prefix, so a common prefix of multiple objects. In my example, it's going to be logs, and I can treat it like a virtual directory. And I'm going to take all my logs, and after 30 days, I can safely assume, this is my example, that the chances of me actually going and looking at these logs is pretty low, but I'd like to keep them around. So I apply a 30-day policy that moves them into Glacier. The moment they're moved into Glacier, the policy becomes effective, my costs go down from 3 cents per gig per month all the way down to 1 cent per gig per month. So I'm saving a lot of money at that point. And then I can add another element into this policy of automatic expiration or deletion of data. So in my example, after a year, I'm thinking, I can delete these logs very safely, but I might forget to do it after a year, so I'm going to automate that. So here, after a year, these logs get deleted from Glacier. This is really good to make sure you don't have data that you don't need, and also for compliance purposes, if you're absolutely obligated to delete certain data sets after a certain period of time. Great customer example that's using these features, SoundCloud in Germany. They're the leading social sound platform for artists. They allow artists to upload recordings into SoundCloud, which will then allow them to share and deliver them into the different mobile device formats and social media outlets. And what SoundCloud does with S3 is when an artist, or I see this now a lot in sports and basketball for athlete interviews, they'll upload the recording into S3. They will transcode it to the different formats that they need to support and deliver them in real time out of S3. But then they'll take the original recording once they're done with it and transition it into Glacier, thereby significantly reducing their capacity fees. So just to recap on Lifecycle Policies, what do you use it for? Data tiering in the cloud. You can use it as a cost mitigation tool for your versioning. You can both move versions into Glacier, then the versions cost you a lot less, or completely expire the versions, control for how long of a time you keep those versions. And then finally, you can expire or delete data by policy from Glacier. So with EC2, you may ask yourself, how do I provide raw block storage to Amazon's compute service and especially how do I deal with highly transactional application. We have two types of block storage services. The first one is instance storage. It comes with the instance. So as soon as you launch an instance, you're going to get a certain measure of instance storage along with it, and it's great for storing temporary data. The disadvantage of instance storage is that it's tied to the instance. So if I ever terminate the instance, my data goes along with it. So if you ever need, and you always need, persistent storage for EC2, this is where you use EBS, Elastic Block Store. EBS is very similar to what you have to storage area networks in traditional data centers. It's a network-based block storage service that's available to EC2 to the EC2 service. So it's not available outside of EC2, just to EC2. It provides a very high level of durability because as soon as you create a volume in EBS, it'll automatically, synchronously replicate itself to another volume in the same availability zone. The way this works is pretty simple. I create the EBS volume. I then create an EC2 instance, and I can then attach the volume to the instance, create a file system, and start reading and writing. Because this is a network service, I can always detach the volume from the instance and reattach it to a different instance. This is very important because we are continuously launching newer instances that have better performance or improved cost, and a lot of times you want to transition to the new improved instance. What this allows you to do is do that without the need for any data migration and do it pretty rapidly and easily. You can attach multiple volumes to an instance. Reason why you may want to do this is because you have an application like an Oracle database where you want to gain separation between different application components, such as the database file and the log file. Or you want to take multiple volumes and stripe them together to gain a larger aggregate capacity or performance. But this is a little bit of a pain, right? Managing multiple volumes, making sure we have enough space in all of them. It's difficult to back up. But why dwell on the past, right? Because a few weeks ago, we've significantly increased the limit, the size limit on our volumes from a terabyte all the way to 16 terabytes with the introduction of larger and faster volumes. And what this allows you to do now is where you used to use multiple volumes, only create a single volume. And when you need to back it up with a snapshot, you now back up only a single volume instead of coordinating snapshots across multiple volumes. This is way easier. But there's a reason why it's called larger and faster volumes. It's because we also significantly increased the speed of the volumes. So with our SSD or flash-based offerings, general purpose, we increased performance all the way from 3,000 IOPS to 10,000 IOPS with the launch. And then with provisioned IOPS, we've increased it from 4,000 all the way to 20,000. Now, for those of you who are not familiar with EBS volume types, let me put it together for you. Let me give you a quick overview of the types and the different positioning. So when you care about performance, which is probably most of the time, you want to use only our SSD-based offerings, general purpose and provisioned IOPS. Magnetic is still around. It's based on magnetic disks, so it's really good for infrequently accessed data or highly sequential data. And it's got a great price point. It's inexpensive at 5 cents per gig per month. But again, if you care about performance, you're going to look first at general purpose. General purpose, as the name implies, is the default volume type. The reason is because it presents the best bang for the buck, the best price for performance offering. It provides you with a very predictable pricing of 10 cents per gig per month. You don't pay for requests or for IOPS, just for how much you store. We provide you with 3 IOPS per gig, so you scale performance as you store more data. But we also provide you with a credit bursting mechanism, so that with small volumes, up to a terabyte, you can burst all the way to 3,000 IOPS. And with larger volumes, again, you can burst all the way to 10,000 IOPS. But certain applications, very highly transactional applications, such as high-end relational databases and NoSQL databases, you may need a very prescriptive level of performance. You may want to dial up the exact number of IOPS that you want to deliver to your application. This is where you use provisioned IOPS, whereas the name implies you provision the number of IOPS that you would like to provide the volume. And you pay a bit more for that. It's a premium offering. So you also pay for the number of IOPS that you provisioned. One of the most important features EBS provides, which I really like to emphasize, is snapshots. What snapshots allow you to do is the moment you turn them on for a volume, we're going to take a full clone of your volume, we're going to compress it, and then we're going to transfer it to S3 to benefit from its superior durability, right? S3 even has more durability than EBS at 11.9s. Subsequent snapshots, we're going to only take the incremental difference between the snapshots, again, compress it, and move it to S3. What that provides you is a really easy backup and recovery facility if you ever run into data corruption issues in your EBS volume. But it's also a great data mobility solution because you can take those snapshots and you can move them to a different availability zone in the same region and even copy them to a different AWS region, which can be used for, to build disaster recovery, to do data migration, and other use cases of a similar type. To summarize, what are the EBS use cases? You use EBS when you need persistent storage for EC2. There's no other way to do it. You use general purpose and provisioned IOPS when you have highly transactional workloads. And you can also use EBS to build a file server or kind of simulate network-attached storage and share file repositories among multiple EC2 instances. But that's pretty complex. So that becomes a lot easier with the new service that we launched today called the Elastic File System. We had a lot of customers who came to us and said, look, my application can really benefit from the economics and elasticity of EC2. But the application requires shared concurrent access into a single file system. And so this is what EFS was designed to provide. EFS relies on 3 simple principles when we designed the new service. It's simple, elastic, and scalable, and I'm going to provide some detail on all of these. What it is at a high level is a fully managed file system for EC2 instances, so you no longer have to worry about provisioning and managing file servers or network-attached storage systems and exposing them to EC2. It's built on standard and simple file system semantics, so whatever you expect from a POSIX-compliant file system, you're going to get that from EFS. It's scalable to petabyte-plus size file systems, so you can pretty much store any volume of data on the service. It's based on flash disks purely, so it delivers very low latency and can accommodate many types of workloads and applications. And it's got high availability and durability built into the service. Some common use cases for EFS include content repositories. So I have a content management system, and most of them were not designed with the ability to interact with S3's APIs. They don't know the concept of an object store. But they were designed to operate very simply with a file system. So now that allows me to very easily migrate these content management systems supporting websites or online publications and run them directly on EC2 with EFS. It's great for development environments where developers are using hundreds or thousands of EC2 nodes and then store their source code, complete build processes, and store their binaries on a set of shared folders and directories. It's good for home directories, not the type of the network drive type of home directories for the corporate user. This is more geared towards engineering and scientific home directories where we want to provide these scientists and these engineers a shared workspace and the ability to also have their own scratch space to run things like ad hoc simulations. And then finally, for big data demands high throughput from the storage system into EC2 and also requires low latency and file semantics and file-level operations, such as file rename, file append, and the ability to read from specific block ranges within a file. These are things that are very difficult to get from an object store in a file system such as EFS provides. So EFS is first and foremost, it's simple. What that means is as opposed to a traditional system where you need to worry about managing disks, managing tiers of disks between flash and mechanical drives to avoid hotspots. I got to worry about striping and RAID and load balancing controllers and controller failovers and all of these things and the networking access into the storage system. All of these things are taken care of automatically and fully managed by EFS. You can create a petabyte scale file system within seconds. It's very seamlessly integrated with existing tools and applications. So it relies on a completely POSIX compliant file system. So again, you can do file system operations such as rename, append, read a block range off of a file, and leverage file locking. And it leverages NFS v4 as file system mounting and I/O protocol, which is commonly used and is supported as a client on all EC2 Linux-based instances. And then finally, it's got a really simple pricing model. You only pay for capacity, you don't pay for performance, which is built in, and you pay 30 cents per gig per month. So it's simple and predictable. It's very elastic. So this file system, as opposed to any other, automatically grows and shrinks according to your usage, and you only pay for the amount of data you store at any point in time. You never have to worry now about provisioning additional capacity ahead of time. We're going to worry about that for you and provision that for you dynamically. And it becomes most interesting in situations where you need to run some sort of analysis that requires a lot of temporary space. In the traditional world, you need to buy a storage system that will have enough space to run these analyses, but then when you're done, it's just sitting there. Here, you're just going to pay for those hours or those days of capacity when you run the analysis. So it's pretty powerful. And then it's scalable. These file systems, you can provision an unlimited number of file systems per AWS account, and each one of them can grow to a petabyte scale or more. Performance grows linearly with capacity. So the more data you put into a file system, the more IOPS and throughput we're going to give you. It's built on flash disks, so you're always going to get low latency for your applications. And then finally, it supports thousands of concurrent NFS connections into a single file system. So this is an introductory presentation. The deep dive already happened earlier today, but you can go back in a few days and watch it on YouTube. But I'm going to try and put it all together for you to show you how simple it is to provision the whole thing, both from a file system standpoint and the client perspective. So the first thing we do is we create a file system. The file system, as soon as it gets created within a few seconds, is spread for high durability and high availability across multiple availability zones. And availability zones are fault-isolated data centers within an AWS region. Once you create the file system, you want to attach a VPC to that file system. VPC is Amazon's virtual private cloud. It's your own isolated network within our compute service. And only that VPC will have access to that file system. Within the VPC, you then create what we call mount targets. Those mount targets can be available in all or some of the availability zones. Those are the NFS endpoints that you attach to your EC2 clients. Then you can use traditional VPC security mechanisms, such as security groups and network ACLs, to further limit the access of these EC2 instances into the file system. And then finally, the administrator can use traditional Linux-based permissions to designate and delegate access to different users. So this basically is all it takes to provision petabytes and provide access to thousands of EC2 instances that are spread across multiple availability zones. So what are the benefits here to the different constituents in the organization? For the IT administrator, it allows them to stop dealing with the muck of managing file servers and network-attached storage, and instead of that, free up their time to deploy high-value applications for the company. For app owners and developers, it means that if I have an existing application that was designed to work with file system semantics, they don't need to now write logic to interact with something like S3 at an API level, and they can very easily migrate the app into EC2 and enjoy the economics and the scalability that it provides. If you have a cloud-native application, you're writing a new application, but you still need a file system level feature such as file locking that you would need to write code yourself to implement on top of S3, because S3 doesn't provide file locking. It's an object store. You can very easily get that with EFS without writing any code. And then finally, for the company, provides very predictable pricing. Pricing doesn't get out of control, and it doesn't require any upfront investment. I don't need to spend any CapEx anymore. I just pay for what I use when I use it. It provides increased agility because even if I have a new project that came up yesterday, I can within seconds make the decision to create petabyte file systems and start deploying a new application. And then finally, the traditional AWS value proposition applied to EFS is that it allows our organization to basically focus on the business instead of the undifferentiated heavy lifting of provisioning, managing, and troubleshooting file servers. Before I move on to Storage Gateway, the next step for you with EFS, it's going to be available in summer, is to go to our website at aws.amazon.com/EFS and sign up for a preview so you can go and test drive the service. So far we've been talking about storing data in the cloud, but how do I move backup and archive data from my on-premises data center in a simple manner into S3 and into Glacier? This is where the Amazon Storage Gateway comes into play. So Amazon Storage Gateway is a virtual machine. You can download it from our website, and you can drop it into a server running either VMware ESX or Microsoft Hyper-V. You then install it in a few minutes, a very simple installation, and you provision some local disk for buffering and caching. The gateway then presents itself into the local network either as an iSCSI interface for block storage access or as a virtual tape library interface. So IT-friendly types of interface that I can mount into my backup software. The backup software can then start writing and backing up data into the gateway. The gateway will then cache all the most recent used data, take data sets, compress them, encrypt them, and persist them into S3 and Glacier, thereby leveraging 11 nines of durability. So this is just a very inexpensive way to move backup and archive into the cloud. It costs you $125 per gateway per month, which is incredibly inexpensive, plus the associated backend costs of S3 and Glacier. So just to summarize what we covered today, our two object storage offerings are S3, which you can use to provide file storage for web-scale applications that are globally accessible to the internet. We have S3, which you can use for infrequently accessed data sets such as deep archives and long-term backup. EBS provides you with high-performance block storage devices for EC2, and specifically provisioned IOPS provides you with a facility for high IOPS, for highly transactional applications. This is very analogous to a storage area network in traditional data centers. And then EFS does a similar thing for file systems and is analogous to a NAS, a network attached storage. Provides you with shared file system access for EC2. And finally, the storage gateway provides you with an on-ramp to back up and archive into S3 and into Glacier. Before we conclude, I just want to ask you to use our mobile application to provide feedback evaluation forms on this session. Shing and I are going to stick around for the next few minutes and do some live Q&A, and then we'll still be around to answer some questions offline. Thank you very much for attending today.